Good morning or good afternoon, depending on when you're starting this. Today is Wednesday, March 24th. This is Asynchronous Wednesday. Our agenda for today, the first task is to complete the Edpuzzle video that you're currently watching. This will be for attendance. This will be I showed up. Your two completion assignments are the two Go formatives from the last 2 days and the two Edpuzzles from the last 2 days. So first off, you're going to correct and complete electrostatics part 4, charging, and Monday item 3, electrostatics part 3, conductors and insulators. I will go over both of those briefly in this video. Last, you will finish Edpuzzles from the last 2 days. This is only if you are not done. Item 4 from the agenda. Item 4, these are makeup. Edpuzzles to be completed are pictured below. You do not have to rewatch them. This is only for students who did not previously complete these. This is not a link. Go to the original link for the posted item in Google Classroom. So for both of these two videos, these are the two assigned the last 2 days. Not everyone finished them, and you need to finish them today. I will be putting them in the gradebook today, as well as both Go formatives, so make sure they are all complete by the deadline stated on the assignment. Now I'm going to go over S2 Week 12 Electrostatics Part 4 Charging. This was assigned yesterday. I've graded it. All these questions have been checked and marked as full credit, no credit, or partial credit. Please correct anything that is not full credit. Number 1, what is one way to charge something? Charging by friction and contact. Not contact, not friction, friction and contact. Many people gave me an example of it, not the way it's done. This says, what is a way to charge something? This is the example. Many people gave me an example here. Please correct that. Number 2, name an example of charging an object. Stroking cat's fur, combing your hair, rubbing your shoes on a carpet. If you did not get this correct, please revert to one of the given answers on the slide. Number 3, electrons transfer from one material to another by, and it says right here, this exact sentence is right here. Electrons transfer from one material to another by simply touching. That is the answer. That's what goes here. Number 4, when charging by induction, is physical contact required? Charging by induction. If you bring a charged object near a conducting surface, electrons are made to move in the surface material, even without physical contact. So when charging by induction, is physical contact required? No. No, it is not. Number 5, if a cloud has accumulated a negative charge on the bottom of the cloud, what charge will be induced on the ground? Here's the cloud. Positive charges on the top, negative charges on the bottom, positive charges on the ground. The question is, what charge will be induced on the ground? The answer is positive. What happens to electrons in any charging process? Electrons are transferred. In any charging process, electrons are transferred. What kind of charging occurs when you slide your body across a plastic surface? Think of a slide in a playground. Many of the answers I got were static electricity, negative, things of that nature. Those are all incorrect. The kind of charging, we're talking about static charging. This entire thing is static charging. What kind of charging? Friction and contact, or conduction. What kind of charging occurs during thunderstorms? So the answer I was looking for was induction, because I was talking about this situation where the bottom of the cloud is negative and it induces a positive charge on the buildings below. But it is true that within the cloud itself, that friction, charging by conduction, does cause the charging So if you put both, or you explained in detail how the friction charging occurs in the cloud, I gave you credit for that. But if you just said friction, I did not give you credit for that. Please correct the answer to show that the charges are induced. Now, if you want to include both, that's fine, but be clear that the friction charging happens in the cloud and the induction occurs between the cloud and the ground. What are the two purposes for a lightning rod? For this one, I literally wanted you to Google it. It says Google it. Here we go. Help us out, Google. Lightning rod, metallic rod, usually copper, that protects the structure from lightning damage by intercepting flashes and guiding their currents to the ground. So those of you who didn't really read this carefully, some people just told me that a lightning rod was a metallic rod. I didn't ask you what a rod was. I asked you what were the purposes of it. So please correct that if you did not completely answer that. What is a lightning rod and how does it protect a building? Let's see. It protects against a direct lightning strike. It channels the lightning to the ground. It prevents fires and damage to masonry and roofs. So essentially, if we take a look at this image here, it directs the electricity away from the building itself. So if we look here at this image, here is the lightning rod. It goes along the roof line, and then at various points, it goes down into the ground. So if lightning hits at any of these points, the current will be conducted through the lightning rod system and into the ground, instead of into the pipes and wiring of the house, causing fires and damage. So it redirects the lightning and it protects the structure from damage and fires. Now I'm going to go over the Go Formative from Monday, Electrostatics Part 3, Conductors and Insulators. I went over this in class on Tuesday, but I need everyone to go back and fix their answers. So you should be able to see the answers, which means that when you look at if you reopen the assignment, you'll be able to see your answer and then the correct answer. Please fix them. Wire metals, good conductors of both heat and electricity, because the atoms that make up conductors have a loose hold on their electrons. Wire, glass, and rubber, good insulators because they have a strong hold on their electrons. Semiconductors are halfway between a conductor and an insulator. They have characteristics of both. For this question, when you buy a water pipe in the hardware store, the water isn't included. When you buy a copper wire, the electrons are included because all atoms have electrons. And as a result, when you buy copper wire, it's made up of copper atoms, which have electrons. So they're included. They are already in the wire. Superconductors are pretty cool because they do not have friction, or they don't have like what's called resistivity. And essentially what resistivity is just friction between the flow of the current. And so when there's no friction, there's no loss of energy due to heat. So if you take your hands and you rub them together, your hands feel warm because of friction. So you use muscle energy in your body, chemical energy, to move your hands. That energy is transferred into friction by the rubbing together of your hands and released as heat. So in a wire, the same thing happens. The electrons have friction, and so they generate heat. Think about when you plug in your phone or your computer, the charger gets hot after a while. That is due to the friction of the current going through the device, and that friction is released as heat. That energy is released as heat, which is basically a loss of the electrical energy. So you want resistance to be low if you're wanting efficiency. Efficiency is how much of your starting amount that you end up with at the end. Okay. How does the flow of current differ in a superconductor compared to the flow in ordinary conductors? So electrons flow without resistance. There's no energy or heat loss like in a regular conductor. And actually, if you're wanting to look at like what an insulator is, essentially it has so much friction that that electricity can't flow through it, because all the electrons are so closely held by all of the atoms and molecules that the electrons cannot flow through it. Um, and that's what makes them an insulator. It keeps you from getting shocked. So think of like a wooden handle on a pot keeps you from your hand from burning. The plastic coating on a wire keeps you from being electrocuted when you touch the wire. And then the last question here was about transistors and just some uses of that. And the answer is listed there for you to view. All right, now we're back to our agenda slide for today. What you just watched is this complete Ed Puzzle video. By answering the questions, you have been marked present. To be marked engaged, you need to complete the corrections on both of these assignments and complete both Ed Puzzles if you have not already. So I went over both of these items 2 and 3, which are the go-formatives from the last 2 days, both Monday and Tuesday. And item number 4 are the 2 Ed Puzzles from the last 2 days. So this as puzzle you're doing right now doesn't count for that. You need to do, if you have not already, the 2 Ed Puzzles from the last 2 days. Most people did finish them, but there were some people that did not complete them or did not do them at all. And just as a reminder, this is what they look like. This is the titles. They were assigned on the 22nd and the 23rd. And I don't remember which period this is a screenshot of, but you can see there are 4 people needed to do this one still, and 6 people needed to do this one. So once those are all complete, you are done. If you are already done with all of this work, thank you for being on task and completing your work when assigned. And you do have no further assignments once all 4 of these things are completed. So both Ed Puzzles from the last 2 days and correcting and completing both go-formatives from the last 2 days.